Okay, welcome back to another video on the Maths channel. It's your teacher, Ms. Lim here, and in this video we're going to be looking at geometric sequences. So by the end of this lesson, you'll be able to explain what a geometric sequence is, which I will refer to as a GP, or geometric progression, which is the same as a geometric sequence, recognize and use the recursive definition of a GP, and use a formula to find the nth term of a GP, and solve various GP-related problems. So what is a geometric sequence? A geometric sequence, also known as a geometric progression or a GP, is a list of numbers where there is a common ratio between each term. The word ratio will always mean some term divided by the previous term. So unlike an AP, where there was a common difference, where it always went up or down by the same value, a GP has a common ratio. So here's an example. We've got 2, 6, 18, 54, 162, 4, 8, 6, 1, 4, 58. The first term, we still use the letter A to represent the first term. And the first term is just 2. But what is the common ratio? Well, to work out the common ratio, we just take any number and then divide it by the previous term. So here, 6 divided by 2, that's 3. We could have taken 162 and divided by 54. If we were to do that, the ratio is 3. Okay. Now for it to be a GP, every single term needs to follow this common ratio. Okay. Alright, so let's test whether each sequence is a GP. For question A, I need to take a term and divide it by the previous term. 20 divided by 40, that's half. Well, let's do the next one. 10 divided by 20, that's also half. 5 divided by 10, that's also half. So I'm going to say, yes, this is a GP. Whoops. Is a GP. Pause the video, have a go with question B yourself. Okay, so we'll take a term, divide it by the previous term. 10 divided by 5, that's 2. Do the next one. 100 divided by 10. Oh, that's 10. The difference already. We can try this one. 200 divided by 100. That's 2. Well, we can see here that they're not all common. The ratio is 2, 10, and 2. So because it doesn't have a common ratio, like this one does, where they're all the same, this is not a GP. Not a geometric progression or sequence. Okay, let's have a look at the second part of this lesson, which is the recursive definition of a geometric sequence. So here we have the formula. Tn is equal to r times tn minus 1, or the nth term, whatever the nth term is equal to the ratio times the previous term. Okay, so if we were to write this out, the nth term is equal to the ratio times the previous term. So let's have a look at some examples. Find the first 5 terms of a GP if the first term is 2 and the common ratio is 4. Okay, so we know the first term is 2 and the common ratio is 4. So all I'm going to do is times that by 4. 2 times 4 is 8. Then times that one by 4. 32. Times this one by 4. That should be 128. Times this by 4. That should be 512. Let me just double check. Yep. And that's it. That's my first 5 terms. So we can see here that they all have a common ratio of 4. because if I were to take any of these terms, for example 8, and divide it by the previous term, I'll get 2. Or if I were to take 32 and divide by 8, I'll get 4. If I was to take this one, divide by 32, I'll get 4. This divided by this, I'll get 4. And that is our GP. Alright, question B. Write the first 5 terms and calculate the 10th term of the GP with A equaling to 7 and a common ratio equaling to 10. So first term is 7. Second term is 7 times 10. Next one times 10, times 10, times 10. Okay, so these are our first 5 terms. We can see that the pattern here is just times 10. And the fifth one has 4 zeros. So the question here says, write the 10th term. Well, the 10th term will just be 7 with 9 zeros. Okay, let's have a look at part 3 of this lesson. Using the formula to find the nth term of a GP. Now to find the nth term of a GP, we use the formula Tn is equal to A times R to the n minus 1. So A is the first term, and R is the common ratio. Okay, so the nth term is the first term times the common ratio to the power of n minus 1. So if we wanted to work out 11, the 11th term, it's whatever A is, whatever the first term is, times R to the power of 10. Because n is 11, so n minus 1 is 10. Or if we wanted to work out the 43rd term, it's A times R to the power of 42, where n is 43, so the power here is 42. Okay. Find the 20th term of the sequence 5, 10, 20. The first thing you need to do is just to make sure that this is a GP. Okay, because it could be an AP, it could be a GP, or it could be neither. Okay, so what we need to do here is see 10 divided by 5, that's 2, and 20 divided by 10, that's also 2. So I can see here that they've got a common ratio and therefore it's a GP. Because it's a GP, I'm going to be using the GP formula for the nth term. Tn is equal to AR to the n minus 1. Remember, if it's an AP, if it had a common difference, so for example, if this had 5, 10, 15 instead of 20, where it keeps on going up by 5, then we need to use the formula for an AP. So the nth term is equal to A plus n minus 1D. Okay, we learned that in our previous video. But this is a GP, so this is what we will be using. So we want to find the 20th term. A is the first term. The first term in this sequence is 5. The common ratio, we've worked it out to the left of here, is 2. And to the power of 19. N minus 1, 19. So we can put this in our calculator. 5 times 2 to the power of 19. Oops. 19. 2621 440 2,621,440. Alright, let's have a look at question B. Find the 8th term of the progression 2187, 729, 243. How about I get you to pause the video and have a go with this one yourself. Okay, so I can clearly see here that there isn't a common difference. So I'm going to test to see if there's a common ratio. So we'll do 729 and divide it by 2187. That's a ratio of 1/3. And let's try the other one to make sure it's common. 243 divided by 729. That's also 1/3. Good, so we know that we are dealing with a GP. So we want to find the 8th term. The first term is 2187, and we're going to multiply it by the ratio to the power of n minus 1, which in this case will be 7, because n is 8. So let's put that in our calculators. 2187 times, let's put it in brackets, 2187 times 1/3 to the power of 7. Oh, and that's 1. Alright, question C. Show that 2 minus 6, 18 minus 54, etc. is a GP and find a formula for the nth term and hence find T6 and T15. Okay, so I'm going to work out what a common ratio is. So minus 6 over 2, that's minus 3. We also have 18 over minus 6, that's minus 3. And minus 54 on 18, that should also be minus 3. Good, so therefore we can see that this is a GP. I'm just going to write that in. Therefore GP with a common ratio of minus 3. Now we need to find a formula for the nth term and hence find T6 and T15. So the nth term is equal to A, which is 2, times the ratio of minus 3 to the power of n minus 1. So what is T6? The sixth term is 2 times minus 3 to the power of 5. 2 times minus 3 to the power of 5 is negative 486. And the 15th term is A times the ratio to the power of n minus 1, which is 14. 2 times minus 3 to the power of 14 is a very big number, 9,565,938. Alright, question D. Find a formula for the nth term of the GP, 5, 10, 20, etc. and determine whether 320 and 720 are terms of this sequence. So it tells us it's a GP already, so we don't actually need to prove that it's a GP. All we need to do is work out what the common ratio is. So the common ratio is going to be 10 out of 5, which is 2. So the nth term is equal to A, which is 5, times the common ratio to the power of n minus 1. Now we need to determine that 320 and 720 are terms of the sequence. So I'm going to sub these values into the nth term, Tn. And when I solve this, if n is equal to a whole number, then it is a term, right? Because n has to be a positive integer. However, if n is not a positive integer, then it's not a term of the sequence. So let's start with 320. 5 times 2 to the power of n minus 1. I'm going to divide both sides by 5 to get 64. 2 to the power of n minus 1. I'm now going to use logs. So I know that log base 2 of 64 is equal to n minus 1, and n is therefore equal to log base 2 64, which I will use change of base law, ln of 64 over ln of 2, plus 1. Let's see what we get here. Ln of 64 over ln of 2 plus 1 is 7. Because that's a positive integer, we know that 320 is a term of the sequence. So I'm going to write here, therefore 320 is a term of the sequence. What about 720? 5 times 2 to the n minus 1. 720 divided by 5 is 144. 2 to the power of n minus 1. So now we've got log base 2 of 144 is equal to n minus 1. So n is equal to ln of 144 over ln of 2 plus 1. Let's see if we get a whole number for this as well. Oh, we don't. 8.17. So therefore 720 is not a term of the sequence. Okay, so from here we can see 320 is a term. As which term is it? It's actually the 7th term of the sequence. So we go 5, 10, 20, and we keep going. The 7th term will be 320. But if we were to keep going, we would skip over 720. 720 is not a term of the sequence. Okay. Question E. The first term of a GP is 448 and the 7th term is 7. Write the first 7 terms. So we've got 448, we've got the second term, third, fourth, fifth, sixth, and the 7th term is 7. So what we need to do here is we actually need to work out what the common ratio is. How are we going to do that? Well, I'm actually going to be using this 7th term is equal to 7. So if I know that the 7th term is equal to, well, let's do it like this. The 7th term is equal to A times the common ratio to the power of n minus 1, which in this case will be 6. But we know that that is equal to 7 because the 7th term is 7. So now I'm just going to divide 7 by 448. That will give me 1 over 64. So r to the power of 6 is equal to 1 over 64. So r is going to equal to the 6th root of 1 over 64. So the 6th root of 1 over 64 is equal to half. However, it's not just half, it's actually plus minus half, because this is an even power. Remember, when we square root, we get 2 answers, plus minus. Same with 4th root, 6th root, 8th root, etc. As long as when we root it and it's an even number here, there's going to be 2 answers. So now that we've done that, we can actually work out the first 7 terms. There's actually going to be 2 lots of answers. So let's start off with when the ratio is positive half. if the ratio is positive half, we're going to take our first term and just times it by half. 224 times it by half. 112. And we can keep halving it. 56. 28. 14. 7. Let's just double check that. 1, 2, 3, 4, 5, 6, 7. Yes, the seventh term is 7. So that is when r is equal to half. What about when r is equal to negative half? We start off with 448. But this time we're dividing by negative half. Sorry, we're multiplying by negative half. That will give us negative 224, positive 112, negative 56, positive 28, negative 14, positive 7. 1, 2, 3, 4, 5, 6, 7. Yep, the seventh term is still 7. Okay, so be careful with these. With these types of questions, there could be two different answers. Alright, question F. Find the 8th term of the sequence 2/3, 4/15, 8/75. Now I'm looking at this and I'm thinking it doesn't look like there's a common difference. In fact, it looks like there's a common ratio, because when I times this by 5, I get 15. When I times that by 5, I get 75. When I times that by 2, I get 4. When I times that by 2, I'll get 8. So it looks like that the common ratio is 2/5. Okay, you can always double check. 4/15 divided by the previous term, 2/3. 2/5. So we want to work out the 8th term. That's equal to a times the common ratio to the power of n minus 1, which in this case is 7. So we've got 2/3 times 2/5 to the power of 7. And that's equal to 256 over 234,375. Alright, question G. Find x if 5, x, 45 is a GP. Well, in this question, we don't need to prove that it's a GP. It tells us that it's a GP, which means we know that they have a common ratio. So if I were to take a term and divide it by its previous term, it's going to give us the same answer as if we take another term and divide it by its previous term, because the two ratios are the same. So all I'm going to do here is I'm going to cross multiply. X squared is equal to 45 times 5, 225. And therefore x is equal to the square root of that. So it's going to equal to plus minus 15. So there are two answers. We could have 5, 15, 45, where we can see here that there's a common ratio of 3. Or there could be 5 minus 15, 45, where it's got a common ratio of minus 3. Either way, there are two answers. X is equal to plus minus 15. Alright, question H. Which term of the sequence 4, 12, 36 is equal to 78,732? So we can see here, this is probably a GP, because it doesn't look like they have a common difference. So let's work out what that ratio is. 12/4, which is 3. And if we were to do 36/12, we will also get 3. So, yep, we've confirmed that it is a GP. So the nth term is equal to a times r to the n minus 1. So we're subbing 78,732 into where the nth term is. And that's equal to 4 times 3 to the power of n minus 1. Divide both sides by 4. 19,000 19,683 is equal to 3 to the power of n minus 1. So we've got log base 3 of 19,683 is equal to n minus 1. So n, I'm just going to do it over here. N is equal to ln of 19,683 over ln of 3 plus 1. And that's equal to 10. So therefore, 78,732 is the 10th term of the sequence. Alright, last one for today. The third term of a GP is 18 and the 7th term is 1,458. Find the first term and the common ratio. So the third term is equal to, actually let's do it like this, a times the common ratio to the power of 2, right, n minus 1. But we also know that's equal to 18. Let's write it as AR squared. The 7th term is AR to the power of 6, and we know that's equal to 1,458. Now we can, pretty much what we've done is we've created simultaneous equations, and we're going to solve this by division. I might actually rewrite this. I might actually swap them around because it might be easier to follow when I've got the larger term at the top. So let's rewrite that. The 7th term, AR to the power of 6, that's equal to 1,458. And the third term, AR squared, is equal to 18. So when we divide this, my a's will cancel each other out. R to the power 6 divided by R squared is just R to the power 4. And what's 1458 divided by 18? That's equal to 81. Now if you were to take the fourth root of this, let's write it like that. Fourth root of 81 is 3, but remember it's plus minus 3. Okay, because when we root it, we can see that that number is even. So there are two answers. Well, if R is equal to 3, what's A equal to? So let's use the first one. The third term. A times 3 squared is equal to 18, because we know when it says minus 3 squared, it's going to give us the same answer. Well, A times 9 is equal to 18. So A is just equal to 2. So that's it. We've worked out that the first term, so maybe we can write it here. First term is 2. And the common ratio is 3 or negative 3. Two answers. So let me just prove that this works. If the first term is 2, and the common ratio is positive 3, so let's do positive 3. Let's go up to the 7th term. So 2 times 3 is 6, times 3 is 18. Yep, that's good. Times 3, 54. Times 3, 162. 486. 1458. 1, 2, 3, 4, 5, 6, 7. Yep, the 7th term is 1458. What if we use the common ratio is negative 3? Or we start with 2. Then it's just going to change the signs for every second one. 2 times minus 3 is minus 6 times minus 3 is positive 18. Negative 54. Positive 162. Negative 486. Positive 1458. And we can see here that the third term is also 18 and the seventh term is also 1458. So that works as well. Okay, so that's it for this lesson. I hope you know how to explain what a GP is now. Recognize and use the recursive definition of a GP. Use the formula to find the nth term of a GP and solve various GP-related problems. That's it from me. I hope you have a fantastic day. This is Mr. Lim signing out. Peace.